The Everglades is often referred to as the River of Grass. Overflow from the banks of Lake Okeechobee once created a vast and slow-flowing sheet of water that ventured south and gave life to wetlands along the way. Unlike most rivers, needlerush and sawgrass filled the low-relief expanses between cypress domes, tree islands, and tropical hammocks. Historically, the wide, slow-moving river gave way to a complex network of unimpeded sloughs and creeks that carried fresh water to the Gulf of Mexico and Florida Bay. At the confluence of fresh and saline water, a vast estuary was formed. Mixing water columns delivered high levels of nutrients, making the Everglades one of the most productive habitats for wildlife in North America. In the late 1940s, however, a massive effort to drain the Everglades began, and canals now divert fresh water away from its historic path and disrupt the estuary. Scientists studying the region soon realized that maintaining the correct balance between freshwater and saline concentrations is key to preserving biodiversity in the Everglades. Over the last 60 years, scientists have documented the slow and steady march of salt marsh and mangroves into what was once a freshwater grassland ecosystem. To see how this shift in habitat affects the southern Everglades and Florida Bay, we can observe a day in the field with Audubon research biologists. To collect their data, biologists travel to remote locations with varying salinity gradients in the southern Everglades. Throughout the year, they monitor water quality at various hydro stations, which measure fluctuating water depths, salinities, and temperatures. This information provides insight to wetland conditions in relation to seasonal water cycles and water management practices. Historically, the change from freshwater to marine conditions was much more gradual and spread over a large expanse of Florida Bay. Today, less fresh water flow has resulted in areas where salinity fluctuates wildly, making the habitat less productive. Biologists at Audubon's Tavernier Science Center explore the relationship between water quality and submerged aquatic vegetation. This habitat is the basic building block of the Everglades and Florida Bay, as it sustains the prey base for all fish-eating birds, game fish, and reptiles. In the most productive areas of Florida Bay, vegetation blankets the sediment. Within these dense mats of aquatic jungle, scientists find clues regarding the health of the ecosystem as species composition shifts with changing salinities. In order to study these underwater communities, biologists endure fickle weather patterns, frequent equipment failures, and unpredictable wildlife. It is required that 2 biologists are present at all times, as they are snorkeling in murky areas inhabited by sharks, alligators, and crocodiles. To survey aquatic plants, a grid is thrown along several transects at each sample site. While underwater, it is painstaking work to identify and count each plant in the grid to determine population densities and species diversity. Analysis of this data enables Audubon scientists to unveil a direct correlation between aquatic vegetation and the amount of freshwater flow an area receives. The Tavernier Science Center will be able to determine the effects of Everglades restoration projects by continuing their submerged aquatic vegetation and water quality studies. Construction of seepage barriers and pump stations throughout the southern Everglades will deliver more fresh water to its original path. This will slow the encroachment of salt water and increase the productivity of the region. Monitoring the ecosystem's response will help Audubon provide feedback to government agencies that manage the restoration projects. The delivery of the right amount of water to the right place will reverse current degradation. In a complex wetland ecosystem, water is the life source and the key to preserving biodiversity. We must re-establish the freshwater flow through the River of Grass to once again return abundant wildlife populations to Florida Bay.